We'll begin today with a definition for tangent. A tangent is a straight line that touches the circle at one point. Now, let's fold this over. You should be able to fold it so that it doesn't quite cover the title at the bottom. And if you would like to, you can also cut these flaps. Now, our first theorem: if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So here's my tangent. It touches the circle at one spot. Here's my radius. And the idea is that if this line is tangent, that means that it must be perpendicular to this radius that's drawn to it. So the theorem in words: in a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. Remember, if and only if means that this works both ways. So a line is tangent to a circle if it's perpendicular to the radius, and if the line is perpendicular to the radius, then it's a tangent. So it works either way. So in this case, for example, line XY is tangent to circle S if and only if line XY is perpendicular to segment ST. So if this is perpendicular to this, then this is a tangent line. The measure of angle STX is 90 degrees because that's what a perpendicular angle is. And the point of tangency is T. That's where the tangent line touches the edge of the circle. The other theorem: if two segments from the same exterior points are tangent to a circle, then they are congruent. Meaning that if these two tangent lines both start from the same point and are tangent to the circle, then they are congruent to each other. They're the same length. So if two segments from the same exterior point are tangent to a circle, then they are congruent. So here, if segment QP and segment RP are tangent to circle C, then QP is congruent to RP. Segment QP is congruent to segment RP as long as they are both tangent to the circle. Now, let's use what we've just learned to figure out the answers to these questions. Use the diagram below to answer the following questions. Assume that MC and MZ are tangents to circle B. So if that's the case, what's the measure of angle BCM? Well, if this is tangent, then I know that it must be perpendicular to the radius. So the measure of the angle would be 90 degrees. Tangent is perpendicular to radius. Find the length of CM if CM equals 5x minus 9 and MZ equals x plus 7. So if these are both tangent and they go to the same point outside the circle, then I know that they're congruent to each other. So CM is congruent to MZ, which means 5x minus 9 is equal to x plus 7. I'm going to subtract x from both sides and add 9 to both sides. And 5x minus x is 4x. 7 plus 9 is 16. So 4x equals 16 divided by 4 on both sides. And x equals 4. So the question is, what is the length of CM? CM is 5 times x minus 9. 5 times 4 is 20. 20 minus 9 is 11. So CM equals 11. Here we're going to find the length of EM if CM equals 12 and BC equals 5. So here's EM. It's part of the hypotenuse of this right triangle. Let's draw it. Okay, so here's my right angle. CM, which is this side, is 12, and BC, which is this side, is 5. Now, I can use Pythagorean theorem to do 5 squared plus 12 squared equals this squared, or if you look at your Pythagorean triples list, you may notice that one of the Pythagorean triples is a 5, 12, 13 triangle. So if the two legs are 5 and 12, that means that my hypotenuse is 13. Now, knowing that, I'm just looking for EM, not the whole thing. So it would be this whole thing is 13 minus whatever this is. This is a radius of the circle. This is the distance from the center to the outside. Every single one of these points is the same distance from the center. So if I know that BC is 5, that's this distance. So 13 minus 5 is going to be the distance that I want. So EM equals 8. If the measure of CBM equals 60 degrees and CM equals 13 square root 3, then find the length of BC. So once again, we're looking at the same right triangle. Only this time they're telling me that this angle right here is 60 degrees. And they're telling me that the length of this side is 13 square root 3. Now, quick reminder about special right triangles. That makes this a 30, 60, 90 triangle. This is the long leg. They're asking me to find the length of the short leg. Remember that the short leg equals the long leg divided by square root 3. So I want 13 square root 3 divided by square root 3. These two things cancel out. So that means that BC is 13. Now find the length of CM if BC equals 12 and BM equals 20. So again, let's draw this same right triangle. In this case, this is 12 and the hypotenuse is 20. And they want me to find this length. Again, I can do 20 squared minus 12 squared equals whatever this is squared, or I can notice that this is one of my Pythagorean triples. It's a 12, 16, 20 triangle. So that means that CM would equal 16. Find the length of XE. That's the diameter of the circle. If BM equals 25 and ZM equals 20. So if this is 25 and this is 20. Okay, so first of all, let's draw that right triangle. Okay, so here's my right angle here. And it says BM is 25 and ZM, which is over here, is 20. Again, this is a Pythagorean triple, or I could do 25 squared minus 20 squared equals this squared, but it's going to be 15 because it's a 15, 20, 25 triangle. You'll find that on your list of Pythagorean triples. So that means BZ, the radius of the circle, is 15. But we're looking for the diameter. Remember, the diameter is double the radius. So XE equals 15 times 2, which is 30. All right, next we're talking about arcs and chords. You can go ahead and fold this paper over to here so it doesn't quite cover the letters on the side for the title. And you can cut these flaps when you get a chance. So first theorem, in a circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So in other words, two arcs, so that's a part of the curve of the circle that's less than half the circle. Two arcs are congruent if the chords, meaning the straight lines that connect those 2 points on the circles, are also congruent. So in this case, I know that the distance from here to here on the outside of the circle and the distance from here to here is the same because this distance and this distance are the same. That means that the arcs are the same. This distance and this distance are not the same because these two chords are marked as being different. So if AB equals 5x and CD equals 3x plus 6, find the length of AB and CD. So we can do this because we can see that the arcs from AB and from CD are both 127 degrees. So the arcs are congruent, which means that the chords are also congruent. So 5x equals 3x plus 6. Then we subtract 3x from both sides. 5x minus 3x is 2x. And divide both sides by 2. X equals 3. That means that A, B, and CD, I just plug it into one of those because they're going to be the same answer. So 5 times 3 is 15. So AB equals CD, which equals 15. They're all the same length. Now over here, they want us to find the value of x. So I can see that this arc right here and this arc right here are both 80 degrees, which means that this chord and this chord are equal to each other. So 12x minus 2 equals 34. You can add 2 to both sides here. 12x equals 36. Divide both sides by 12. X equals 3. Okay, in a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So here, this shows that this radius is perpendicular to this chord. That means that it cuts the chord exactly into 2 equal halves. So this length and this length are the same. And that would also be true if we were talking about a diameter that goes all the way across the circle. So that means that this and this are the same, and because they're the same, that means that the arcs next to them are also cut into equal halves. Given that chord BC is 15 centimeters from the center of circle A, which has a radius of 25 centimeters, find BC and DE. So this circle has a radius of 25. That means the distance from the center to any point on the edge is 25. So this is 25, this is also 25. I also know that this chord is 15 centimeters away from the center, because that's what it tells me. 15. And that makes this right triangle a Pythagorean triple. It's a 15, 20, 25 triangle, which means that this is a distance of 20. So BD is 20. I know then, because this is perpendicular, that this is cut into 2 equal halves, so this is also 20. So BC is 40. I also know that since this is another radius, it's a distance of 25 minus this 15 equals 10, which means that this distance here, DE, is equal to 10. Now find AD, CD, and the measure of angle, or so the measure of arc AB. Okay, so what are some things that I know? I know that this whole length is 6 because it's a radius, just like this is, and they're both 6. I know that this is a 30, 60, 90 triangle, and I've got the hypotenuse, which means this is the short leg. Remember that the short leg is half the hypotenuse, so that means that this is 3. So CD equals 3. I also know that the long leg is the short leg times the square root of 3. So AD right here is 3 square root 3, because that's the short leg times square root 3. Now for the measure of AB, it just wants to know basically what's the angle from here to here. And I know that this bisects the chord, so it also bisects this arc. This one is 60 degrees, which means this is also 60 degrees. 60 plus 60 is 120. So the measure of arc AB equals 120 degrees. Finally, in a circle or congruent circles, 2 chords are congruent if and only if they are equidistant from the center, meaning that this chord and this chord are the same length if the distance from the center is the same, if these 2 lines are congruent. So if these 2 lines are congruent, then that means that these 2 lines are congruent. In circle A, FG equals 3, GA equals 5, and AH equals 4. Find PJ and LA, so find these 2 distances. So first, this is a right triangle, and I recognize it as a 3, 4, 5 right triangle, right? If this is 4, this is 5, this must be 3. This is one of those Pythagorean triples. And if this is 3 and this is 3, that means that these chords are the same distance away from the center, which means that these chords are congruent. So if I can find one, I'll find the other one. I also know that this radius is perpendicular to this chord, which means it cuts it exactly in half. So this chord is 4 on this side and also 4 on this side. 4 plus 4 equals 8. So LA is equal to PJ, and both of them have a length of 8. In circle A, FG equals 3x minus 4, and HJ equals 14. Find the value of x. So this tells me that they are the same distance from the center. They're both 2 away, which means that they are equal to each other. So 3x minus 4 equals 14. I'm going to add 4 to both sides. 3x equals 18. Divide by 3. X equals 18 divided by 3, which is 6.